Example number 3 is big A equals 43.3 degrees. Little a equals 31.2 feet. And little b equals 36.8 feet. Okay, again, you don't have to draw the triangle. I just prefer to in order to do the problems. Makes me feel better. Okay, so big A, big B, big C. We know big A to be 43.3 degrees. We know little a to be 31.2 feet and little b to be 36.8 feet. We are looking for big B, big C, and little c. Maybe I should make my big A a purple because he was given. Okay, so because we know big A and little a, we are definitely going to be using sine of big A over little a equal to, we need to use sine of big B over little b because we know little b. You don't have to keep writing it like this. I am fine if you just start filling it in at this point. Like sine of 43.3 degrees. And that's over our 31.2. Sine of, we don't know big B yet, over 36.8. We need to get sine B all by itself, multiply both sides by 36.8 to get our sine of big B is equal to 36.8 sine of 43.3 degrees all over 31.2. Again, who takes a number, spits out angles. Our B is going to equal sine inverse of 36.8 sine of 43.3 degrees divided by 31.2. And we type that in our calculator. So sine inverse of 36.8 sine of 43.3 degrees divided by 31.2, and that gives us a big B of approximately 53.9899. Because I gave you these two sides to one decimal place, that's where I will ask you to round, so it's actually 54.0 degrees. But what we just did in the last chapter with our equations, we know that sine of B is equal to a positive number in two quadrants. What two quadrants does that happen in? Oops. That happens in Q1 and Q2. And my question to you is, if this is my B, 54 degrees in Q1, can this angle in Q2 with a theta slash of 54 degrees also potentially be an angle in a triangle? And the answer here is yes. So we actually didn't find just B here. We found what I'm going to call B slash. And my B slash is approximately 54 degrees, or my reference angle. So my Q1B, which I'm going to call him B1, is approximately 54.0 degrees. But there's also a Q2B, which I will call big B2. That is approximately this angle from here to here. To find that angle, we do 180 minus the 54. Clear, 180 minus 54. And he is approximately 126.0 degrees. Okay, so the question right now is, can this B2 work in our triangle? We knew big A to be 43.3 degrees. We just found two big B's, a 54 and a 126. So next we go to big C1. And 180 minus 43.3 minus 54.0 is approximately 82.7 degrees. What about big C2? So again, 180 minus our 43.3 minus 126. 180 minus 43.3 minus 126 gives us a C2 of 10.7 degrees. And so far we have two potential triangles that might both work. And so from here we keep going. We found big B and got two answers for him, which led to two answers for big C, and we are still a possible triangle. The final guy that we need to find is little c, and so we need to find two of him. So in order to do that, I do know we're going to have to use a rounded answer for big C1, but we're going to not use that many roundeds, which is why we go back to what we were given to keep it as accurate as possible. So we're going to do sine of our 43.3 degrees divided by our 31.2 equal to sine of big C1 over little c1. Oh, sorry, big C1, we do know he is 82.7 degrees. And we're solving for little c1, so we cross multiply little c1 times sine of 43.3 degrees is equal to 31.2 sine of 82.7 degrees. To finish solving for little c1, we divide by sine of 43.3 degrees for 31.2 sine of 82.7 degrees divided by our sine of 43.3 degrees, and we type that in our calculator to get our little c1 is approximately, so 31.2 sine of 82.7 divided by sine of 43.3, and little c1 is approximately 45.1 decimal place, 45.1 and our units here are feet. And our second triangle that so far hasn't violated being a triangle at all, we're going to use sine of our big A again, 43.3 degrees divided by 31.2 equal to, this time we're going to do sine of big C2, which is 10.7 degrees divided by little c2. Again, if it helps you to write it out with the letters in there first, I'm fine with that. If you don't need to, I'm fine with that too. Cross multiply to get our little c2, sine of 43.3 degrees equals 31.2 sine of 10.7 degrees. Little c2 is equal to 31.2 sine of 10.7 degrees divided by sine of 43.3 degrees. And then we put that in our calculator to get that little c2 is approximately 8.4 feet. 8.4.